the pancreas, pineal gland. That's basically what we have left. Pancreas is unique, right? It has both endocrine and exocrine functionality, secretes a number of digestive enzymes, and it secretes a couple of very important hormones, which you should probably have an understanding about, since this is something that affects the vast majority of Americans. Diabetes. Pancreatic islets, the islets of Langerhans. Pancreatic islets is the name that they're trying to use. I don't think I asked, is it pancreatic islets or islets of Langerhans on the exam? If I was to ask a question about diabetes, if you called them islets of Langerhans, fantastic. It is important to know, I will say, even though I don't have it underlined, is you should know that these are secreted by specific cells, alpha cells and beta cells, okay? Because it is, the loss or the burning out of the beta cells that are the diagnosis of type 1 and type 2. Type 1 diabetes, you do not have beta cells. Type 2, you've burnt them out, basically. Those are the most common ways that, overconsumption of sugars and born-like. I get it. There are other ways that you can lose your beta cells, okay? You could have trauma and develop type 1 diabetes. So, I get it, all right? I'm just talking about the most common ways, all right? I don't want to talk about every single way. There she blows. There's the pancreas. Pancreas, stomach sits right here, if you remember. The duodenum, the first 12 inches there. Gallbladder, common bile duct, pancreatic duct. Oh, God, so many fun things there. So let's look at insulin and glucagon, because those are the two hormones that we're talking about here. Insulin and glucagon are there to regulate sugar balance within the blood. The primary individual for that is insulin. All right, again, it's secreted by the beta cells. And when blood glucose levels rise, that's when insulin gets secreted. Again, its purpose is to lower blood glucose. So what's its function? Lower blood glucose levels. It facilitates the uptake of glucose by cells. And it's pretty interesting how it does that. It does that by binding to a receptor. Okay, nothing new there. But that's not the receptor that actually brings in the glucose molecule, the sugar. As you can see there, insulin binds to an insulin receptor. And it specifically binds, or it specifically tells, I guess I should say, the cell to secrete glucose transporters. And they're called GLUT transporters. Specifically a GLUT4. GLUT1, GLUT4, those are the two primary ones that are generally, are discussed in class and whatnot. There are like 15 of them, 14 of them, 20 of them. I can't remember, 14 of them. I don't know, something like that. There's a number of them, and they're usually very specific for the type of tissues and cells and whatnot that we find them on. So it is specific. But these GLUT transporters, and specifically GLUT4 transporters, are what are going to be found predominantly in skeletal muscle, fat, and that's what we generally discuss when it comes to those two things. So it's these transporters, GLUT1, GLUT4. I have GLUT4 here. This one, the one the book talks about. It causes the cell to, as you can see, make those glucose transporters, make those GLUT transporters. And it facilitates their insertion into the plasma membrane. Again, insulin binds to an insulin receptor, specific. And then it causes a cascade of events inside the cytoplasm. It causes the cell to make and put glucose transporters on its surface. Skeletal muscle, adipose, liver, those are the places that we store, utilize sugars, a heck of a lot more than any other cell or tissue. Skeletal muscle is where we store sugar long term for a little bit. Liver is where we store sugar for a little bit. Adipose stores everything in excess. So that's its primary action. It facilitates the uptake of glucose by a cell by inserting a glucose transporter, specifically GLUT4, into the plasma membrane. As you can see there, it also is going to help stimulate. Oh, yeah, there you go. See? Glycogen. Booyah. I don't care about the enzyme. But it facilitates the long-term storage of glucose. When you are actively doing something, you burn through your stores of glycogen. Glycogen is just hundreds of glucose molecules strung together. That's it. Okay. So we get this glucose in, utilize it, and we start to rebuild our war chest, our stores of it. And insulin helps to facilitate that action, to promote sugar storage, which is to say to make glycogen. It stimulates adipose tissue to store fat. Okay. Let's talk about that one for just a quick second here. It stimulates adipose tissue to store fat. So it stimulates the production of fat. The opposite of that would be lipolysis, right? Lipolysis, lipid to, lysis to destroy a lipid. And we do that when we want to facilitate utilization to make a lot of energy to repair a lot of stuff. Here, this is just after I ate a meal, okay? Let's just say. So I've got plenty of glucose there that the cells can utilize. So do I need to break down lipids over here around my midsection? No, because I have plenty of glucose here within the blood. Plenty of it within my meal that I'm eating. So this will stimulate adipose storage. Okay, it stimulates the production of adipose. Insulin does. I mean, we're making things. Okay, I am making adipose. I'm making glycogen. I'm building things together here. So this is anabolic. Okay, this is an anabolic type of hormone here. Glucagon is the exact opposite. It is secreted by alpha cells when blood glucose levels are low. Its one job to raise that blood glucose levels back to normal levels. That's its job. That's its function. How does it be stimulated to be secreted? When blood sugar levels drop. Excuse me. Okay. How does it? Well, just like insulin, glucagon binds to its specific receptor. And then you can see this kickstarts a secondary G-coupled protein reaction. I mean, G-coupled protein reaction, oh crap, there's that secondary messenger again that we always see all the time. Pancreas, glucagon helps to facilitate the breakdown of glycogen. Stimulates the liver to break down glycogen. There you go. You can see it there in step 7. Okay, we've activated a specific enzyme that will go in and actually, chew up glycogen, releasing glucose molecules. And as you can see, it's another glut transporter. I didn't ask about that one. But it's a different transporter that actually pumps it out of the cell. Okay, pumps it out of storage. This thing also stimulates gluconeogenesis. Okay, that's glucose from a new source. It also stimulates lipolysis. Oh, crap. Okay, so here is my destroyer. Here is my catabolic hormone in this process. Here now I'm calling, now it's like, okay, my blood sugar levels are falling. When does this happen? Every time you go to sleep. Every time you go to sleep, you get into this position here. We'll call upon your glycogen stores, burn through those, call upon your lipid stores. Okay? Lipolysis, we destroy those triglycerides, release those free fatty acid chains into the blood, which now my cell can use to make energy out of. So after we've blown through our glycogen stores in our cells, again, skeletal muscle, liver, adipose, okay. After we've blown through our stores in our skeletal muscle in our liver and released it into the blood, and it's been picked up and levels are still not sufficient enough, hello, call upon my lipids. What if you burn through all your lipid stores? I mean, that's crazy, right? That's not going to happen in a day. That's starvation. And that's when glucagon is going to start stimulating gluconeogenesis, the breakdown of proteins. To get glucose. Some amino acids are glucogenic and they make glucose. Some are ketogenic and they make ketones. Here, I'm just showing you some examples. There is no way in God's green earth that I'm going to ask you anything about those glut transporters. Okay. Really, the only one we talked about was the one involved with skeletal muscles. Okay. That's the only one I've asked or potentially asked on the exam. As you can see, I mean, they're very specific. See, there's GLUT4. Adipose and muscle. These are the one that we talk about. But you can see, I mean, they're very specific. So you can target specific receptors here with medication. See, pancreas has their own glut transporters. Heart has a few, brain has a few. I mean, it's pretty interesting when it comes to these things.
Would glycogen also be an alpha cell, or would that just be glucagon?
Glucagon is from the alpha cell. Okay. That's the hormone that's going to be released. Glycogen is our long-term storage form of glucose.
Okay, just making sure.
You bet. And again, the primary places that would keep that is skeletal muscle, liver, fat. But the first two are the primary ones. So if I was to ask you on an exam, So if I was to ask you on the exam, what in the world is going on with diabetes mellitus, we have many different types of diabetes. Diabetes mellitus is the most common one that we're going to be talking about. Excuse me. That's where we have type 1 and type 2. Okay. Type 1 is generally you're born without them. Okay. Your body has mounted an immune response and destroyed these beta cells. Type 2 is basically insulin resistance. You have so much sugar that the carbohydrates that's in your diet, generally simple sugars, simple carbohydrates that are in your diet, that the body's like, okay, oh, there's more of you here. Okay, well, I'm going to pump out a little bit more. And you continue to eat nothing but crap and sugar, and it just keeps it just keeps squirting out all the time. And after a while, it just it gets burnt out, and it puts a ton of stress and strain on these beta cells, and so they become numb to the situation. They become numb to the situation. So then they start becoming overactive. And then they eventually just burn out. With type 2, type 1, you can't treat it. You can't cure it, I guess is the best way to say it. You can treat it. You treat it with insulin injections because you don't have the dang cells. With type 2 diabetes, you can generally cure it with diet and exercise. The diet part is usually what gets in the way of those individuals. You can take medication. Nothing wrong with that. One of the first side effects of metformin is sugar imbalance. What is diabetes mellitus? Sugar imbalance. Unless you get a hold of your diet, you usually don't ever get off metformin or whatever drug you want to take for it. Okay. Can it? Yes. Vast majority, no. Diabetes mellitus, type 1, type 2. I know I'm going to ask a question or two about it on the exam. Gestational diabetes, this is the one that you see during pregnancy. It usually will go away after you birth the creature. So only about 4% of pregnancies have it, but type 1 and type 2 is the most important ones to kind of know there.